So today we're going to learn how to write and balance chemical equations. So my first two slides are just steps. So like if you are someone you like to write down the steps so you have steps to follow, that's our first two slides. And then we'll do 4 practice problems together where we'll actually apply those steps. Okay. So the first step is we just determine the correct formulas for all reactants and products. And I'm going to underline if we want to shorten the words. So you have to get the correct formulas first. Okay. So that's why I chose the review on the warm-up. But if you can't get the correct formula, do you have any hope of balancing your equation correct? No. Okay, there's 0 hope. So you have to take your time. You have to work on getting the correct formula. Most of the time, it's going to be like making sure you do that crisscross rule. Okay. And then we're just going to set up our equation. We're going to do that skeleton equation we talked about on Monday. So just making sure reactants are on the left side of the equation, products are on the right side of the equation. And then in order to balance, you have to know your quantities that you're starting with. Okay, so then you just count the number of atoms of each element you have on both the reactant side and the product side. And then just one little tip or trick I have for you, and we'll do some examples and I'll show you what this looks like. You're going to count polyatomic ions as a single unit. Okay. And I'll show you that in an example of what I mean by that. Okay, so then our next step, we're just going to start balancing elements one at a time using coefficients. And again, we'll do some practice problems together. But coefficients are the small whole number in front of the chemical formula. So let's just do an example of water. What's the formula for water? Okay, so then when we balance, you're going to add a coefficient right here. Let's say we're just going to make it 2 waters. Okay. So the large whole number that comes in front, this is the coefficient. Okay. So when we balance, you can only add a coefficient. You can never ever change subscripts. So what I mean by that is when we're balancing water's H2O, you can never touch this 2. Okay. So we're only going to change coefficients to balance. And then when we're finished, you're just going to double check. Okay, balancing is a lot of guess and check. And so at the end, once you think you're balanced, take the time to go through it one time and just make sure that it actually is balanced, correct? And then finally, check your coefficients. They do have to be in the lowest possible ratio. So if you can reduce them by a common denominator, you have to reduce them. So we're going to do 4 practice problems together. Okay, and we'll look at just different scenarios, and I'll share different techniques. The first one, I give you words just mainly to force us to practice writing some formulas again. Okay. So we have silver nitrate plus copper yields copper 2 nitrate and silver. Silver nitrate was part of our warm-up today. What's the formula for silver nitrate? Okay, so we're going to AgNO3. And then what's the symbol for copper? Okay, yields is just that arrow. And then we have copper 2 nitrate. So again, when we write that formula, we have to do the crisscross rule. So what's the charge in copper 2 nitrate? Okay, plus 2. And then if you look at the back of your periodic table, what's the formula for nitrate? So we have NO3 minus 1. What do you do with those charges now? Switch. Okay, crisscross. So we end up with Cu, NO3, 2. And what do we have to do so those 2 subscripts aren't touching? Okay, so parentheses. And then silver, what's the formula for silver? Ag. Okay, so this is step 1 and step 2. So you have to get the correct formulas. Okay. So if you see copper 2 nitrate, remember, pause, take your time, and make sure you do that crisscross rule so you get the correct subscripts down here. So now the next step is just to count the quantities of the atoms you have to start with. I find it easier if we just make a tally right below. So what's the first element you see? Silver. So I'm just going to make a list below. So there's silver on the left side of the equation, and there's still silver on the right side of the equation. How many silvers are on the left side? Okay. Just one. And then how many are on the right side? Okay, one. Okay, next, this is my little tip about polyatomic ions. So nitrate is NO3. Do you see how it's NO3 on the left side? And do you see how it's still NO3 on the right side? Okay, my piece of advice for you is keep it together, meaning don't break it up into nitrogen and oxygen. Keep it together and treat it as one thing, and I promise it'll make balancing much easier for you. So if you look at the left side, how many nitrates are there? Okay, just one on the left side. And then if you look at this side, how many are on this side? Okay, two. And then finally, the third element is copper. How many coppers are on the left side? One. And then how many are on the right side? Only one. Okay. So this subscript, it only applies to what's in the parentheses here. So just one copper. Okay, so the tally is nice because it helps you see this is what you're starting with. And it helps you see, so silver is already balanced, copper is already balanced, so we really need to focus our efforts on the nitrate. Okay. So if there's two on this side, you have to add a coefficient. So what coefficient are you going to add right here? 2. Okay. So we're going to put a 2 right here in front of the whole compound. And so then this 2, it distributes to both the silver and the nitrate. All right, so now we are going to change our tally. Okay, so now how many nitrates are on the left side? 2. It also changed my number of silvers. How many silvers are on the left side? 2. All right, so now silver is not balanced, so what coefficient do you have to add over here? Okay, so we're going to add a 2 over here, and that changes our tally. Okay, so now it looks like we're balanced down here, correct? The final step is just go through your equation once and make sure it actually is balanced. So you have 2 silvers, and how many silvers? 2. Okay. Then this 2 distributes. You have 2 nitrates, and how many nitrates? 2. How many coppers? 1 and 1. Okay. Are we balanced? Good. If no coefficient is written, I'm just going to change my color. A 1 is implied. Okay. We don't write the 1s. Can you reduce the coefficients any further? Like between 2, 1, 1, and 2. Can you reduce this any further? Okay, so it means we're good. So that's our full balanced equation. All right, here's our next example. This one, I already gave you the formulas. So we have aluminum plus oxygen, and it gives us aluminum oxide. Okay. So first, let's just list our elements. So we have aluminum and aluminum. And then what's the second element present? Okay, so oxygen and oxygen. How many aluminums are on the left side? 1. How about the right side? 2. How many oxygens are on the left side? 2. And how about the right side? 3. Okay, for this one, we have 2 oxygens and 3 oxygens, so let's start there. Those will be harder to balance than the aluminums. Okay. Here we have 2 and here we have 3. So when we have this situation, we probably want to look for like a common multiple of those 2 numbers. So what's a common multiple? Okay, 6. So let's try to get both sides to 6. So what coefficient would you need to put here to get it to 6? Okay, 3. And then in case we aren't aware, coefficients and subscripts always multiply. Okay, so it's 3 times 2. Okay, So we have 6 on this side. And then what would you have to add here to get this oxygen to 6? Okay, so I'm going to put a 2. And again, they're going to multiply. So what's 2 times 3? Okay. So we have 6. And then did this also change my number of aluminums? Yeah. Okay. Again, they're going to multiply. So it's 2 times 2. Okay. So we have 4 aluminums. So now what do you have to add on this side? 4. All right, and then before you move on, what's the last thing you're going to do? Just double check. So we have 4 aluminums, and 2 times 2 is 4. So 4 aluminums. We have 3 times 2, which is, okay, so 6 oxygens, and then 2 times 3, which is 6 oxygens. Okay, let's look at example 3. So we have SiCl4 plus H2O gives us H4SiO4 plus HCl. Whew, whoa. This one's more, right? Okay, we're still just going to break it down by element. So what's the first element you see? Okay. What's the next element you see? Okay. Next element? And the final element? Okay, and then remember, last class we talked about the law of conservation of matter. So whatever elements are on the left still have to be on the right. Okay, so if we just look at the left side, do we also cover what's on the right side at the same time? Good. Okay. For this one, I want you to try to at least add up the initial quantities on your own. Okay, so look at the equation, count how many silicons, chlorines, hydrogens, and oxygens there are. While you do that, I'm just going to take a lap. Okay, let's check our initial counts. How many silicons are on the left side? Okay, just 1. How many are on the right side? Okay, also 1. Okay. How many chlorines are on the left side? 4. How many are on the right side? Just 1. How many hydrogens are on the left side? 2. How many are on the right side?
5.
Okay, 5. We have how many here? 4 plus 1. Good. And then oxygen on the left? Okay. 1, and then oxygen on the right? Okay, so now we have to balance. Okay, we can see silicons balance. It doesn't really matter which element you start with. Okay, from here, it just kind of becomes guess and check and some problem solving. None of these are going to be easier than the other. If it were me, I'd probably just pick on my second one, and I'd start with chlorine. Okay. So if there's 4 on this side, what could you add over here to get it to 4? Okay, so let's write a 4 here. Okay, so now it changed our hydrogen count. How many hydrogens are here? 4 plus how many? So what's our total? Okay, so now I'm just going to keep going down the list. So silicon's balanced, chlorine's balanced, so let's go to hydrogen. There's 8 on this side. So what coefficient can you add here to make it 8 on the left side? Okay, why 4? Good, because you're going to multiply it by this 2. So let's put a 4 here. Okay, so 4 times 2 becomes 8. And then did that also change your oxygens? Yes. Okay, so now how many oxygens do you have? Also 4. Okay, so down here, do you look balanced? Okay, hold on. Make sure you give me your attention here. So down here, we look balanced, yes? Okay. Balancing does just become a lot of guess and check. So sometimes you might have a lot of like erasing and rewriting. So always make sure you just go back one more time just to make sure. So one silicon. How many chlorines? 4 chlorines, and this 4 distributes, so 4 chlorines. 4 times 2 is 8, so 8 hydrogens, and 4 plus 4 is, so 8 hydrogens. And then how many oxygens? Okay, this 4 distributes, and how many over here? 4. Are we balanced?
Yeah.
Good. Okay, so for our final example, this is one of the trickier ones, but we're going to learn a trick. Okay, the trick is going to require erasing. So do we have a pencil? If we don't, write light, because we'll erase. Okay. So the first thing I just want you to recognize, I want you to get used to this pattern. Okay. So if you have something, this is called a hydrocarbon. Do you see how it's this molecule with hydrogens and carbons? Okay. And then we're combusting it, so you're just adding oxygen. And then your products are CO2 and H2O. Okay. So whenever you kind of see a bunch of carbons and hydrogens, and especially this O2 by itself, this is a type of reaction. It typically requires really big coefficients. So I'm going to teach you a trick of like how we can get to those big numbers without it taking forever. So step 1, we're still just going to list our elements. So what's the first element you see? Okay, so we have carbon. What's the second element you see? And then what's the third element? Okay, so now we'll count our numbers just like we always have been doing. So how many carbons on the left? 7. How many on the right? Okay. 1. How many hydrogens are on the left?
6.
Okay. How many hydrogens are on the right? How many oxygens are on the left? Okay, 2 plus 2, which is 4. And then how many are on the right? Okay, 2 plus 1, which gives us 3. Okay, so as we do more of these, and we're going to notice this pattern that we have this O2, you're going to save O2 for the very end. Okay, so it doesn't matter if you start with carbon or hydrogen, but you're just going to save oxygen for the end. Personally, I just start with carbon because it's the first one. Okay. So if there's 7 carbons on this side, what coefficient do you need?
7.
Okay, so I'm going to put a 7. This is where you're going to write light because we're going to end up erasing. Then we're going to go ahead and balance our hydrogens. There's 6 on this side, so what coefficient do you need? Good. Okay, so then 3 times 2 will give us 6. Now we're going to tally up our oxygens all on the right side. Okay, and remember if you have a coefficient and a subscript, you're going to multiply them. So what's 7 times 2? 14 plus, how many oxygens are here? 3. So what's 14 plus 3?
17.
Okay. So there's 17 total oxygens on the right. So that means we need to get 17 total on the left. Okay. This one is going to be hard to change because it's attached to carbon and hydrogen. We don't want to change those because we're already balanced. Okay. So how many are right here? 2. We have to get to 17. So what's 17 minus 2? Okay, so that means right here we have to make this one equal 15. What number times 2 equals 15?
7.5.
Okay, so you're going to lightly pencil in a 7.5. And again, right here, if no coefficient is written, what number is implied?
1.
Okay, so technically, is this balanced? Technically, it's balanced. Now, do you think you can have a coefficient of 7.5? You can't. So here's the trick. We already know the ratio. So all we're going to do is double these numbers, and that'll turn this into a whole number. So if you have a pencil, like erase and rewrite, I can't erase up here, so I'm just going to write dark. So what's 1 doubled?
2.
Okay, so that'll become a 2. What's 7.5 doubled?
15.
Okay, so this is going to become 15. What is 7 doubled? Okay, so that becomes 14. And then what's 3 doubled? Okay, this one becomes 6. Okay, so now we did a lot of guess and check. We did doubling. Should we definitely check our work? Okay, what's 2 times 7? Okay, so 14 carbons. And how many carbons? 14. Okay. What's 2 times 6? Okay, so 12 hydrogens. And what's 6 times 2? 12 hydrogens. And then finally for oxygen, we have 2 times 2, which is 4, plus what's 15 times 2? Okay, 30. So how many total oxygens on the left side? Okay, 34 total. And then on the right side, we have 14 times 2, which is, okay, 28 and 6 distributes. What's 28 plus 6? 34. Are we balanced? Good. Okay, and are these coefficients all in like the lowest whole number ratio?